Dr. A here. In this video, we are going to be exploring an example of solving a system of equations using the graphical method. So let's go ahead and start by writing our given information. And so again, our problem statement is to solve the system using the graphical method. State if the system is consistent or inconsistent. Okay, so the graphical method works the most efficiently when you have two equations with two unknown variables, and you basically do what the name suggests. You graph the equations on the same set of Cartesian axes, and where the two lines intersect represents a solution, okay? So our system that we are given is going to be x plus y equals 3. This is still given information. And then x minus y equals -1. All right, so let's go ahead and write solution here. And what we're going to do is graph each linear equation, okay, on the same xy axes. All right, and so in order to graph these pretty conveniently, it's usually pretty convenient to write the equations in slope-intercept form. So let's write that down. Let's write the equations in slope-intercept form. Now you can look at that first equation and you can easily see all we need to do is solve for y, and we'll get y equals -x plus 3. And then looking at the second equation, we can rearrange this and we'll get y equals x plus 1. Now that we've written our two equations that are in our system in slope-intercept form, it's really convenient and pretty simple to graph these, since we can easily graph linear equations when we can visualize them in slope-intercept form. So I'm going to go ahead and sketch out a set of Cartesian axes. So this is my y-axis. Always label your axes. And this is my x-axis. So remember, your y-axis, positive y, is oriented up, negative y is down, positive x is pointing to the right, negative x is pointing to the left. All right. The next thing I'm going to do is go ahead and scale off my two axes with values. All right. So to scale off a set of Cartesian axes, it's usually convenient to just look at your equations and look at the values of your equations, okay? And then from those values of your equations, you can get a pretty good idea of how you should scale off your axes. So I'm going to scale mine off up to 5, okay? So I'm going to call this 5 right here, and I'm going to call this, 1, 2, 3, 4, 5. Now that's not perfect, okay? That's not perfect, but you can try your best, to make these look as nice and organized as possible. 3, 4, and then 5 is up here. And then let's go ahead and make this a little bit longer down here. -1, -2, -3, -4, -5. And again, on your own paper, maybe write this a little bit better than what I'm writing here. I'm just doing it kind of quickly here. 4 and then -5. Okay. So next thing we can do is go ahead and sketch these graphs. Let's look at the first equation here. We have a slope of -1 and a y-intercept of +3. Okay, so if you remember from previous classes, a y-intercept of +3 is the point 0, comma 3, and your slope is -1. So that means that you're gonna have a decreasing slope, right? So another point you can plot would be 1, comma 2, and then you can plot a point, 2, comma 1, and you can plot a point, 0, comma 3, and you can connect these like so. And again, I'm freehanding this, so on your own paper, it'd be a good idea to use some kind of straight edge and scale your tick marks off evenly, since you could do that more easily on paper. So this is that first equation, y equals -x plus 3. Let's plot the second equation. The second equation has a slope of +1 and a y-intercept of also +1. So our y-intercept is going to be right here, and our slope is going to be increasing. So we're going to rise 1 and run 1, and look at that. We happen to already have found the intersection point right here, and we can plot a few more points as needed, and we can throw a straight line through that. And of course, this is y equals x plus 1. So the solution is where these lines intersect, all right? So we're going to write this here. The solution to the system is where the lines intersect. So the solution is the ordered pair 1, comma 2. And so I'm looking at that, and I know that because here's the intersection point, and this intersection point has an x value of 1 and a y value of 2. So another way we can write this solution is, we could say, or x equals 1 and y equals 2. So that is our solution. And because the solution has at least one, the system has at least one solution, the system is consistent. And that concludes this example video. If you like this, go ahead and hit like and subscribe, and you can check out some more of my videos on this topic as well as some other topics.